Now, I want to describe the transformations in order from the graphs of f to g. Okay, let's real quick talk about the order of our transformations. Now, keep in mind it goes horizontal, something, horizontal something, horizontal something, and then vertical something, vertical something, and vertical something. So on the outsides, they are shifts. So let me put those both down. Okay? Then the second ones in are stretches slash compression. And the two middle ones are reflection, reflection. Now, however you like to think about it, going horizontal, 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 vertical, 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 we go shifts, stretching, compressions, reflections, and then reflections, and we just basically go backwards with those types of transformations. Okay, so let's check out number 11. If we're going in order, the first thing I'm going to check is if there's any horizontal shift. And indeed there is. The -3 tells me I'm going to go right 3. So remember our horizontal transformations are, remember the little hint we remember is opposite because it's often opposite of what it initially looks like. Go right 3. There is no horizontal stretch or compression. That would show up as being multiplied right there. There is no horizontal reflection. There would be a negative right there. So then I'm going to go on to vertical reflection. Vertical reflection. There is not one because there is no negative sign there. There is a vertical stretch or compression. Since I'm multiplying it by 2 right here, it is a vertical stretch of 2, and that means I would multiply all my y values by 2. And then lastly, I'm going up 1, shift. Okay? Number 12. I'm going to go left 2. No horizontal stretch or compression, nor reflection. No vertical reflection, nor vertical stretch or compression. I'm sorry, I don't know if I said that right. No vertical reflection. And then the next thing we check is a vertical stretch or compression, which we have neither. But we do have a vertical shift of down 2. Okay, let's check out number 13. I've got a shift left 4. No horizontal stretch or compression, no horizontal reflection, but I do have a vertical reflection, okay, or reflection about the y-axis, and then I can go down 4, okay. 14, 15, 16, these are cubic root functions, cube root functions, I should say, okay. Same, I'm looking for the same thing, so this tells me I'm going to go right 1. There's no horizontal stretch or compression, no horizontal reflection, no vertical reflection, no vertical stretch or compression, but there is a shift up 1. Okay, let's move on to 15. All right, left 2, and then vertical reflection, or reflection about the y-axis. Stretch, and I want to say vertical stretch of 4. We don't want to go down, we want to go up 3. Number 16. Right 1, no other horizontal transformations, no reflections at all. There is a vertical shrink by a factor, and I'll say by a factor of 2, because I'm going to divide everything by 2. And up 4. Okay, so that's through 16. Now, 17 through 34. I certainly gave you plenty to practice. I'm not going to go through all of these, but I will leave a key up so you can go back and check your answers. Okay, but I will go through a few of some of the ones that kind of get repetitive. 17, I'm trying to get x by itself, so I would need to square both sides. All right, that gets rid of the square root, and then I get x equals 16. If I go back and I check it, square root of 16 is indeed 4. Okay, yes, we consider the negative 4 sometimes, but for problems like this, we are not worrying about them. Okay, 18. Okay, I do want to get the n out of that square root, but first I got to take care of this minus 3. So to do that, I'm going to add 3 to both sides to get 11. Then I get the square root of n, and then again, I'm going to go ahead and square both sides. I get 121 is equal to n, okay? And I'm going to go ahead and check that. 8 is equal to the square root of 121 minus 3. Square root of 121 is 11. If I subtract 3, I will get 8. Okay, so that one's good. So do check your solutions, guys, because there will be some that do not work. Okay? 19 is very similar. The only other little thing is first I would add 15. These cancel. So I get -1 like this. Then I would take and square root, divide both sides by 3. Oh, this is supposed to be add 15. So this would become, let's see, 9. Oops. 9, this would be 3. And then this would be a equals 9. I could go in and check this and it would work. Okay? Same steps for a cube root function. So let me look at maybe one of the harder ones right here. Okay, I guess I can go through these quickly. This one, I'm going to cube both sides. So 5 cubed is 125. This is going to be equal to x. I would go through and check, and that would work. Here, I'm going to cube both sides again. Okay, I get -27 is equal to x plus 2. Subtract 2 from both sides, I get -29 equals x. And then I want to go ahead and check that, and that should work. 22, or problems, so problems like 22, 26, 27, 28, 29, 30, 31. Notice they have the roots on both sides. Okay, and then even, no, that's all. Okay, what I'm going to do here is just cube both sides. So let me take this, cube, raised to the power 3, then I get 7m minus 3. This will be equal to m plus 9, and then I just solve for m. I get 6m is equal to 12, m is equal to 2. Double check that it works, and it will. Okay, just like if they were squares. So let me maybe pick one with a fraction in, because I'm sure some of you guys would like to see that one done. I'm going to square both sides here. Get 2v over 3 plus 10 is equal to 4v minus 10. And I'm going to solve for v. Now I kind of like to just multiply everything by 3 to get rid of that denominator. When I do that, I get 2v plus 30 equals 12v minus 30. Okay, so I kind of just get rid of those fractions. Now let's see, I'm going to get 10v on one side and 60 on the other. V will equal 6. I can check that, and it will indeed work. Now, problems that I want to look at, 31, it's very similar, only I would start by moving the square root of 6w to the opposite side, and then I would go through and then square both sides. Okay, so that one's going to be very similar to the other ones that are highlighted. Let's check out 32 through 34. Okay, so it does say check for extraneous solutions, and that's not just to say it, there could be, and these are cases where I might get an extraneous solution. So let's check this one right here. This one's a little bit tougher because I have the square root already by itself, so I want to square it. That means I need to square this. Now, it is not, when I do this, this is not k squared plus 36. It is not that. Okay, so remember, do not make that mistake, and we've talked about that in the past. It is k plus 6 times k plus 6. And then now I got the 2k plus 15 out of the square root. All right, I need to FOIL the k plus 6 times k plus 6. And when you do that, you get k squared plus 12k plus 36 is equal to 2k plus 15. I'm going to set everything equal to 0, so I'm going to move the 2k plus 15 over. I get k squared plus 10k plus 21 equals 0. You could maybe try the quadratic formula, but I do notice that these factor out nicely. Okay, so k plus 7, k plus 3. So this gives me k equals -7 and k equals -3. I do need to check them. So let me go back and review what this looked like here. Okay. Let's try the k equals -3 first. Okay, if you do check that, it will be okay. Now let's talk about why this one will not be okay. If I were to plug that in, I would get -7 plus 6 is equal to the square root of 2 times -7 plus 15. And then I have -1 is equal to -14 plus 15, or just the square root of 1. Now, you got to be careful here. Whenever I have a square root on one side and a negative value on the other side, a negative constant, I should say, it will give me, the solution will not be true. It will be an extraneous solution. I know you're thinking, and we've been getting into the habit of considering the square root of something having a plus or minus answer, and we're thinking that square root of 1 is plus or -1, so that could work. However, we're only considering the positive case. Now, to quickly prove why this would not work, if I had -1, backtracking to what we had, and then the square root of 1, actually, let's not necessarily here. If I was to do this over here, and I'm going to have to erase this in a second, but if I go here and I plug this into my quadratic formula, this would be -10 plus or minus the square root of 100 after I square 10 minus 4 times 1 times 21 all over 2. Let's check here. Did I do my math correctly? I think so. Now -10 plus or minus square root of 100 minus 88 all over 2, and then I get -10 plus or minus 12 all over 2. Alright, let's figure out where this is not quite working out how I was hoping it would. -10 plus or minus 100 minus times 1.